Now, after having said this, we come to our next speaker, who is Professor Christian Gehl. He is Professor for Chemical Technologies with a specialization in powder metallurgy. And he will talk now, as mentioned already earlier, about the specialization in high-performance materials. And I just have to start the presentation. And we are ready to go.
Thank
Please,
you, Peter.
Christian.
Okay, I will talk about the specialization block of high-performance materials. And first thing I want to emphasize on is what are high-performance materials. That might be a lot of materials. That might be materials that are working at high temperatures. That might be materials that work at high temperatures. That might be materials that react differently than others, that have functional properties. That might be polymers. That might be steel with special properties, and so on. So, but not only a steel, yeah. That might be starting from a steel sheet, coming to a powder. Yeah, I'm working a lot with powders. So there is a lot of opportunities of high-performance materials, and that's the way we structured this specialization block. No, that's the wrong one. So we have the blocks you have to do mandatory. This is the fundamentals of materials technologies. So we need to know what is going on with our materials. So we have to do some basics here. Physical chemistry of materials differs a little bit on the physical chemistry you have already learned about. We are mostly talking here about phase diagrams, how to derive properties from these. This means from the thermodynamics, from the statistic of thermodynamics to the electrochemistry, and to do to get some properties we want to have. On the other side, we go deeper in the material science. We start with a small excursus into theoretical chemistry, build up their structures, and ending up with materials we are testing mechanically or functionally. And then we go up. We scale up. We are talking about metallurgy and materials processing. This is really, especially in part, heavy industry. So we are talking about steel making of other metals, like copper and nickel and titanium and aluminum maybe. Yeah. Also involved theoretical parts and practical work there. But not only metals, we have also ceramics in the course. Ceramics are also very often used in high performance, and if they are cheap, this is also some kind of high performance. So we are talking here about properties of production and performance of these ceramics and the applications, and as ceramics react a little bit differently than metals on the mechanical loads, this has to be taken into account here. On the other side, we are not doing this specialization block alone in CTA. We are also cooperating a lot with other institutes and parts of the institutes, like the Synthesis Institute. Here, Professor Liska is doing polymer materials, because also here you find a lot of high-performing materials that are produced in industry, and it's very important to know these, especially when you combine them with other materials to composites and compounds to get new materials like structured materials you can use in airplane construction and so on. So really, really extremely high-performing materials. And for sure, as everybody who is synthesizing a material wants to know what he has synthesized, so there is also a strong part in characterization of these materials. It has to be, yeah. You have to shoot with the fancy instruments on your materials to find out what you have done, what the properties are, and why the properties are there. Yeah. This means you have to know the surfaces that are interacting with the surrounding, with a lot of different methods. I did not learn these fancy names from analytics like Jürgen did. Yeah. And a lot of properties are coming from the structure of the material itself, so therefore we need to know the structures of the materials, and this has to be deeply investigated by different methods. Yeah? And here we have a new professor that is doing this lecture, I think now for the second time, and he will guide you through this course. And finally, you get hands-on. We are making these high-performance materials in the lab. For sure, we will not make a big steel sheet, but we will produce some parts with different methods. We divided that to a metallic part and to a ceramic and electrochemistry part, because interaction is complicated, and it is. We had this lecture together once, but from organizational viewpoint, it is better to divide it, so it's easier for you to choose when to do the job, to do the lab course. We are doing a synthesis and a characterization of a special material, of an additive manufactured steel, of a high-performance ceramics here to be used in a fuel cell. And you will see if it works finally. If you've done everything wrong, then your fuel cell will produce some current. And then you have these elective exercises. Now you can choose. Yeah, you have the full choice. 3 of them you have to complete completely. No, 2 you have to complete completely. And the rest you can choose whatever you want. So you have a lot of things you can choose from. And finally, you will make a diploma thesis. That's the crown of everything, yeah? The big ending. Yeah? And for sure, the seminar where you present your work. Here I have given you 2 examples of diploma thesis. I have supervised in the last years one with materials of defined porosity. I saw sheets of titanium and porous copper parts produced by the student, and another one now so-called powder strengthened aluminium with boron carbide, which is used for storage of nuclear waste. So, if you want to come to us, I've given you a lot of names already during the lectures. Approach the lecturers if you want to do your elective courses. You will meet them again in the lab courses, in the mandatory lab courses, and in the lectures. And so you can choose wherever you want to go for your master thesis, and hopefully you will have fun with your final examination and master thesis. Thank you very much.
Thank you, Christian, also for your presentation. High-performance materials are
Who's next?
High-performance materials are a very important class of materials, and quite a number of groups are working in this area as well.